One of the most captivating and potentially historic astronomical events that scientists eagerly await is the explosion of Betelgeuse into a supernova. Betelgeuse, also spelled Betelgeuse, is a red supergiant star located in the constellation Orion, famously occupying the position of Orion's right shoulder. This colossal star, visible to the naked eye, has long fascinated astronomers due to its immense size, brightness, and especially its erratic behavior. Red supergiants like Betelgeuse represent one of the final stages in the life of massive stars. Unlike stable stars such as our Sun, which have relatively predictable life cycles, red supergiants are volatile and unstable, with significant variations in brightness and mass. These characteristics make Betelgeuse not just a star in the sky, but a dynamic cosmic laboratory for studying the life cycle of massive stars. In late 2019, the star's unpredictable nature took center stage when its brightness began to noticeably decline. For centuries, Betelgeuse had been one of the most luminous stars in the night sky. But during this period, its brightness dropped significantly, drawing the attention of both amateur skywatchers and professional astronomers around the globe. The phenomenon was so intense that the star visibly dimmed to the naked eye, sparking widespread speculation about whether this was a signal that the star was on the verge of exploding. This unprecedented event came to be known as the Great Dimming. Telescopes were quickly trained on the star, and researchers scrambled to collect data in hopes of understanding what was happening. Was this the beginning of the end for Betelgeuse? Betelgeuse, or Alpha Orionis, is classified as the second brightest star in the Orion constellation, just behind Rigel, though it remains the most discussed and scrutinized due to its peculiar characteristics. Its name, derived from Arabic, means the armpit of the giant, a poetic reference to its position within the mythological figure of Orion, the hunter. Despite being technically outshined by Rigel in terms of brightness, Betelgeuse's red-orange glow and immense size give it a visual dominance and scientific allure. Its apparent magnitude fluctuates between plus 0.0 and plus 1.3, making it the 10th brightest star in the night sky and the 7th brightest as seen from large parts of the northern hemisphere. One of the most intriguing aspects of Betelgeuse is its sheer scale. It is estimated to be around 700 times larger than the Sun in diameter. If it were placed at the center of our solar system, its outer surface would extend past the orbit of Jupiter. The star is also shedding mass at an extraordinary rate, losing about 1 solar mass every 10,000 years. This expelled material forms a vast, glowing nebula around it, extending out to a diameter of approximately 30 astronomical units, AU, 30 times the distance between Earth and the Sun. Remarkably, this nebula is about 250 times larger than the star itself. These ejected gases not only shroud Betelgeuse in mystery, but also contribute to the complex processes that enrich interstellar space with heavy elements and dust, vital for the formation of future stars and planets. At the heart of Betelgeuse, like all stars, nuclear fusion is the engine that powers it. During its early life, Betelgeuse fused hydrogen atoms into helium. But now, having exhausted most of its hydrogen, the star has moved on to fusing helium into heavier elements like carbon and oxygen. As this fuel depletes, fusion progresses to even heavier elements, eventually forming iron in the core. Unlike earlier fusion reactions that release energy and keep the star stable, the fusion of iron consumes energy. Once a critical mass of iron accumulates at the core, the star can no longer support itself against gravitational collapse. The result is catastrophic. The star implodes, creating a core collapse and triggering a supernova explosion. This process releases an enormous amount of energy and creates a shockwave that blasts the star's outer layers into space. Throughout history, observations of Betelgeuse have intrigued astronomers across cultures. The ancient Greek astronomer Ptolemy described the star as having a color he referred to as ruddy or reddish, while Chinese astronomers recorded that it appeared yellow centuries ago, suggesting that Betelgeuse may have once been a yellow supergiant before transitioning into its current red supergiant phase. Stars like Betelgeuse are known for their short, dramatic lives. While our Sun is expected to last over 10 billion years, Betelgeuse's total lifespan is only around 10 million years due to the rapid pace at which it burns through its fuel. All evidence indicates that Betelgeuse is in the final phase of its stellar life, though though the exact timing of its death remains uncertain. Astronomers have identified 2 brightness cycles in Betelgeuse, one of which occurs approximately every 5 years and lasts around 100 days. These cycles are believed to be caused by the expansion and contraction of the star's outer envelope, which affects its temperature and radius, leading to observable changes in brightness. The events of 2019 and 2020, where the star's brightness dramatically dropped and then rebounded, drew global attention. Scientists debated whether these fluctuations were a sign of an impending supernova or simply an unusual surface phenomenon. Despite the speculation, observations indicated that the core of the star remained stable, and there were no significant infrared changes during the dimming, suggesting the event was likely caused by surface dust or mass ejection rather than internal collapse. Another aspect that adds to Betelgeuse's intrigue is its high velocity through the galaxy. The star is traveling at about 30 kilometers per second through the interstellar medium, having been ejected from the Orion OB1 stellar association, a group that includes the famous belt stars of Orion. This motion creates a shock wave or bow shock in the interstellar gas ahead of it, stretching for over 4 light-years. Measuring the size and distance of red supergiants like Betelgeuse is a complex task, as the star pulsates and its outer layers expand and contract over time. Moreover, the circumstellar envelope of dust and gas influences how the star appears from Earth. The observed size of Betelgeuse can vary by up to 35%, depending on the wavelength of light used to measure it. In July 2009, the European Southern Observatory's Very Large Telescope Interferometer captured dramatic images of a massive gas plume extending $30 from Betelgeuse's atmosphere. This ejection, similar in angular size to the distance between the Sun and Neptune, was one of several recorded over the years. At least 6 major mass ejections have been observed, and these may hold the key to understanding how massive stars like Betelgeuse shed their outer layers before exploding. The exact mechanism behind these violent outbursts remains a mystery, though advances in interferometry are helping scientists unravel the complex dynamics of red supergiants. Then, in 2019, researchers using the Hubble Space Telescope and other observatories detected what they described as a surface mass ejection, a massive event in which Betelgeuse expelled a significant portion of its surface. Unlike the solar coronal mass ejections we observe from our Sun, this event was thousands of times more powerful, releasing a mass of material over 400 billion times greater than a typical solar outburst. This sudden and intense ejection likely caused the sharp dimming of Betelgeuse observed in October 2019. By mid-February 2020, the star's luminosity had dropped by more than 2/3, decreasing from magnitude 0.5 to 1.7. Interestingly, by February 17th, Betelgeuse's brightness had stabilized, and there were signs it had stopped dimming entirely. Astronomers noted that the event, while dramatic, was not linked to a core collapse, further suggesting that the dimming was surface-related rather than an indicator of an imminent supernova. In conclusion, Betelgeuse remains one of the most enigmatic and closely observed stars in the sky. Its life is nearing its end, and while we don't know exactly when it will explode, the day it does will be one of the most spectacular cosmic events ever witnessed by humanity. The explosion will not pose any danger to Earth due to its distance of about 640 light-years, but it will light up the night sky, possibly brighter than a full moon, and remain visible for weeks or even months. Until then, scientists will continue to watch Betelgeuse with great interest, waiting for the moment this celestial giant writes the final chapter of its stellar story.